Hi everybody, and welcome to today's video, which is on the subject of the nature of wood and how much wood moves. That's going to be the first part of this video. We're going to talk about expansion and contraction in wood. We're also going to talk about the kiln drying and air drying process, and how to buy timber, how timber is sold in sawmills and in builders' yards. But first I would like to talk about how much timber actually moves. So all timber, all solid wood moves with changes in humidity. So it expands and contracts with changes in humidity. How much is a bit of trial and error, because it depends whether the wood is dried or not, and whether it's air dried, whether it's kiln dried, or if it's actually just freshly cut, if it's soaking wet. If you freshly cut a piece of wood that's soaking wet and you were to take it into a warm house, the wood would most likely split and it would most likely be unusable, because it would dry out so fast. So basically, in terms of, on average, wood moves, it's about 1%. It's a bit more for some woods, maybe 2%. Doesn't sound like too much, but if you have a piece of wood that's a metre long and it moves 1%, well, a metre is 1,000 millimetres, so 1,000 divided by 1% is 10 millimetres. So over a span of 1 metre, that wood could be 10 metres longer or shorter, depending the time of year and the humidity, basically. So it doesn't sound like much, but it's something you do need to factor in when you're building things, and you need to work with it, because it's not something you can stop. It's very, very powerful. Wood will just move. It's not something that we can stop. You've just got to work with it. So you can dry timber to try and help to eliminate this. It won't always work. It won't always eliminate it, but you can do timber drying either in a kiln or air drying. So a kiln is basically just a big oven, and pallets of wood are put in. Now before they're put in, what they need to do is, the pallets of wood are built up in such a way that there's a layer of planks of wood, but then there's some sticks or pins to separate the wood, because you can't have pieces of wood right on top of each other, or else they'll just hold water forever. They'll never ever dry. So you need to have little pins spaced quite close to each other along the length of the timber pack, in order to allow an air gap so that air can flow through, and so that when it goes into the kiln, so that the hot steam in the kiln can actually flow through in order to dry the wood. So going back to the kiln, it's just a big oven, and the pallets of wood get put in, and there's different cycles for different wood. So some woods don't need long in the kiln at all, and depending on the temperature as well. Each sawmill knows what cycle they need for what species of wood, and if it's hardwoods, they might need longer, because they might actually be dried down further than softwoods. Some hardwoods are actually dried down to about 6%, as low as 6%. Most softwoods round about here anyway are generally about 10 or 12% moisture content, and you can check that with a moisture meter. You can buy a moisture meter in any DIY store, and if you just buy it, it's just battery operated. And you just, it's two prongs. You just basically touch the two prongs on the wood, and it'll tell you the moisture content. So what's the difference between kiln dried and air dried? Well, air dried is, as the name suggests, it is dried out in fresh air. You can't have it completely outside, otherwise it wouldn't be protected from the rain. So you need to have a roof over it. But it doesn't need to be enclosed. It can be just a lean-to. It can be just a shed with open sides, as long as it's protected from the rain, and it will dry in there. One of the biggest cons to air drying is actually the time that it takes, because it's about, roughly per inch of wood, it's about a year you need to let it dry for. So if you have planks of wood that are 2 inches thick, you would need to let them dry for 2 years, air dry for 2 years. Whereas a kiln, you know, could be a matter of weeks and it might be dry, or even less time than that. So that's the biggest con of air drying. However, air drying produces much better quality wood in general. It does, not always, but normally it does. It's got better grain, and usually less defects. It's less prone to splitting and twisting, warping, etc. Whereas kiln drying, maybe because it's getting dried at a faster rate, there's a better chance that the wood will actually form defects such as warping, bowing, etc. But again, there's a bit of luck involved in it. Actually, you never really know, with wood being the natural product that it is, you never really know what way it's going to go. You could have a very expensive piece of wood and it could still warp, it could still become unusable. There is a bit of luck involved in it. So I'm going to look now, moving on from that, I'm going to look at some timber defects now. So one defect you can get in timber is to have a piece of wood, or this is called a cant, when it's cut right from the centre of the tree. So you can see the very centre of the tree in there. This has been cut right from the centre of the tree, and this can cause all sorts of problems. This can cause something called star shakes, which are basically checks. They're splits along the wood, and because they're coming out from the centre of the tree, it can affect the end grain. The end grain can actually shake. The reason why this one hasn't really is because I've cut quite a bit of material off of this one. I've cut all the waste off, so there was shakes on it, but I've cut them off. You can see a bit of that here. You can see a bit of splitting here. This isn't the worst bit, certainly not the worst I've ever seen, but there is a bit of splitting here. This bit isn't actually too bad considering, and what can happen as well when it's cut from the centre of the tree is you can get a bit that looks like this. So this here, that was actually the dead centre of the tree, and it's basically just fell out because it's almost like dead wood at the centre, and there's nothing holding it on to the other wood, to like the heartwood. So the centre of the tree has just fallen away basically, and it's left this sort of gouge here. So just bear that in mind if you see wood cut from the direct centre. Here we have quite a common defect. This is called cupping, and it's when the board, across the width of the board, bends like that. So this is a piece of skirting board, although it definitely couldn't be used as skirting board now because of this bow, this cup, sorry. It's essentially a bow but across the wood, across the width of the wood, and this is quite a severe example. This is only about not even 4 inches wide, and it's quite serious. So that's cupping, or a cup. This here is if you get wood like this is known as bark edge, or waney edge, or sometimes live edge. This is where the actual tree bark is still on the wood. This has been cut from the very outside of the tree, and they've tried to cut a board from this, but there hasn't been enough wood. They've reached outside of the tree, and of course it's left the bark on the wood. So that's waney edged wood. So I've got a piece of wood here that has several defects. This piece here, and if I can just show you. So this has all sorts of defects. This is, if you can see right down the length of that, this has what's known as a bow. So a bow is when, hopefully you can see that, it's going like this, in this direction. That piece of wood is bowed. It also has what's known as a crook, which if we turn it that way, it's going now in this direction. And it also has quite a serious twist in it as well. As you can see on the video, the end of the piece of wood, the other end, not this end, the other end is sitting flat on the bench, and you can see how much of an angle there is on that. I would have to lift it up to here to be able to straighten it out. You can see how twisted that is. That really, it doesn't have a lot going for it, that piece of wood. It is a piece of oak, but it's very poor quality oak. So here's another example of a bow, just to give you a quick idea. You can see the wood is sort of banana shaped. It's not straight, it's very, very curved, very, very bowed. So that's just another example of a bow. So the other thing that some woodworkers like to do when they're drying timber, whether it's kiln dried or air dried, is they will get the end of the timber and they'll actually paint the end of the timber, or you can use diluted PVA glue, and because the timber dries quicker on the end grain than it does on the edge grain, it'll stop the end grain from drying so quickly if you just paint it. That's why whenever you go into a sawmill or a builder's merchant, all the hardwood will probably have like a green paint or blue paint on the end, or sometimes red paint on the end. That's what the purpose of that is. So when you go to So the next part of the video is to do with actually buying timber and how timber is sold. So timber is sold in a lot of different ways. It's sold rough sawn, planed, kiln dried, heat treated, pressure treated, dip treated, all sorts of different ways. There's also structural timber. Most of the time, an average DIY store or builder's merchant, you will generally be buying rough sawn timber, which will be like whitewood, spruce typically, or it will be redwood, and occasionally you'll find hardwoods such as oak or Meranti. So the way that wood is normally sold is by the linear meter. So this means each running meter of wood, each linear meter of wood will have, when a sawmill quotes you a price, they will quote you a price per linear meter. Some sawmills, particularly if you're buying, like if you were to be buying a full lorry load of timber, they would probably sell it by the cubic meter. And people probably think, well, what's that? I don't understand cubic meters. Well, it's not difficult at all to work out. You can convert linear meters to cubic meters very easily. As long as you know the price per cubic meter, you can easily find out what price a linear meter is, or what price one length of wood is, by going by the price of a cubic meter. So back to back to actually buying the wood. So if you go into a builder's merchant, most builder's merchants are willing to work in metric or imperial. Myself, I always work in metric when I'm measuring it anyway, or when I'm building projects. I don't ever work in imperial. You might hear me saying certain measurements in imperial, but I'm not actually measuring my wood in imperial. But if you were to work in imperial, if you go in and ask for a length of 4x2, you'll find probably you may be lucky, because there is some tolerances actually. So 4x2 might not actually be 4x2, even if it is rough cut. It may be just slightly under 4x2. So the approximate metric equivalent of 4x2 is 100x50. The most common size of 4x2, if you like, in the UK is 100x47, if we're talking about rough sawn timber. So it's not actually 100x50, it's actually 100x47. And this is really just based on companies taking a little bit off each, they're trying to make more money basically. It used to be 50mm and now it's 47. So they're just shaving a little bit off every time. So that's rough sawn wood, 100x47. But you could go in and it could be, I've seen rough sawn wood that should be 100x47 that's only 95x47. And that's just tolerances. That's just something that you need to kind of work with. So it's always best to go in and select your own wood wherever you're buying it from. Always go in and select your own wood. Don't phone in a delivery or something and just let them pick it and just see what arrives. Always go in and pick your own wood and try and get it all as close to the right size as possible. So if we move on to planed wood now, planed wood is a bit different because planed wood has to run through a planer in all four sides. So all four sides have been planed. So planing takes off about roughly 3mm on each side, sometimes a wee bit more than that. So what was once 100x50 or 100x47 might now be 95x45, or even less, might be 90x40, depending on where you go. The size should be specified by the builder's merchant before you buy it. It should be on the receipt as well, what the finished size is. But if you buy a length of 4x2 or 100x50 that's planed, it will definitely not be 100x50. It will be more likely to be 95x45. And this also applies to what we call regularised timber, which is actually it's sort of like rough timber, but it's a bit better quality, and it's sent through a planer on all four sides, and it also has an eased edge, which are four eased edges, which mean that the corners are rounded, the edges of the timber are rounded. So that's regularised timber, and regularised timber is also graded timber, meaning that it's graded C16 or C24, which basically means it's a structural grading system. So C16, if you are building an extension, for example, and on the architect's drawing you need to use graded timber, it will probably specify which grade you need to use. Whether it's the most common are C16 and C24. C24 it's about 50% stronger than C16, but it's a lot more expensive. But whatever's on the drawing, that is what you need to use. So the other thing that's very widely available, and I think a lot of people are probably familiar with it, similar to regularised timber, is CLS. So CLS is really common in two sizes. There's actually three sizes of it, but it's common in two sizes, that being 38x63 and 38x90. There's also 38x140, but that's not seen so much, it's not so common. So now in terms of the 38x63, for example, that's actually known as 3x2 CLS, even though it's nowhere near 3x2. So 3x2 would be 75x50. So why is CLS called 3x2 when it's actually only like 2.5 by 1.5? Well, the reason for that again is the planing. It goes through a planer and it's also eased edges all round, and that's just what's lost in the planing process. So CLS is normally used for framework and partitions and shed bases and shed framing and things like that, where it's ideal to have all the wood the same size. That's the benefit of CLS. You can all the wood you pull out the pile will all be exactly the same size. It's not like rough sawn timber where there's a lot of variation. It should all be pretty much exactly the same size. Okay, so to convert linear meters into cubic meters, I'm starting off here with a square. I've drew a line down here to draw an approximate square, and I know that my 200 by 50 was only available in 2 metre lengths at a cost of £5,000 per cubic metre. So I need to find out how many lengths of 200 by 50 is in a cubic metre. It's very easy to do. So we know that there's 1,000 millimetres in a metre. So I'll just mark 1 metre and 1 metre. So it's 1 metre across here, 1 metre down here, and it's also 1 metre front to back as well. That's a cubic metre. So the size we have, 200 by 50, so we need to find out how many times 200 goes into 1,000. That's 5 times. And how many times does 50 go into 1,000? 20 times. So we need to times 5 by 20, which equals 100. And that tells us that there's 100 linear meters of 200 by 50 in a cubic metre. So we now know that it's £5,000 per cubic metre. So I know there's 100 linear metres in a cubic metre, so to get the price per linear metre we need to divide 5,000 by 100, and that gives us £50. £50 per linear metre. And the only length that I could get was, of course, 2 metres, so £50 times 2 equals £100 per length. So that was the length of a 200 by 50 at 2 metres teak. Now, if we turn the tables and suppose we want to convert, suppose that we know the price per linear metre but we don't know the price of a cubic metre, we can do another simple calculation, which is, let's suppose we're talking about 50 by 50, and let's just say it's rough sawn. In reality, if you bought 50 by 50 it would most likely be smaller, but we'll say it's 50 by 50. Species of wood doesn't matter in this occasion, but 50 by 50, and let's suppose it's £2.55 per linear metre. So we know the price per linear metre, so what we need to do again is find out how many running or linear meters there are in a cubic meter. It's very easy to do, so just need to find out how many times 50 goes into 1,000 millimeters in a meter. So 50 millimeters goes into 1,020 times, and again same at the other side, 20 times. So 20 times 20, 400. So there are 400 linear meters of 50 by 50 in a cubic meter. So 400 linear meters, and we know that the price per linear meter is £2.55. So if we just do a quick multiplication, 400 times £2.55 55, and we get £1,020. Okay, so just to quickly recap, so if we need to find how many linear meters are in a cubic meter, all we do is we take the size of the timber. So if we go back up to the top, 200 by 50, so we divide 200 by 1,000. How many times does 200 go into 1,000? And then how many times does 50 go into 1,000? We times the two numbers together to get the linear meters, and then if we know the price per cubic meter, all we do is divide that by the linear meters and the linear meter price, and we will, sorry, the cubic meter price, divide the linear amount of linear meters by the cubic meter price, and we will know the price per linear meter. Same down here, we found 50 by 50, which goes into 1,020 times, so we know that if we were to build a cubic meter of 50 by 50, we would be 20 lengths wide by 20 lengths deep, or 20 lengths high, which would give us a total of 400 lengths, and we knew the price was £2.55 per linear metre, and we just do 400 times £2.55, and that gave us our price of £1,020. So just before I end the video, one thing to note when you're buying wood, or buying really anything for that matter that has VAT or VAT, is that make sure the total cost that they give you is including VAT, because myself have been stung with that 2 or 3 times where I've thought I'm been getting a great price and realised that there's 20% VAT to be added on, and all of a sudden the price is not quite as great. So just be careful of that. Whenever you are asking for a price in a builder's merchant, they may not always as standard give you the price including VAT, so make sure you ask for the price including VAT. So that concludes today's video. I hope you enjoyed that. I hope it made some things a bit clearer, and I will see you in the next video.